Hi, good morning, welcome back. We're going to the sum of central angles today. This will help you measuring angle marks. Go ahead and sum. I'm heading into my notes. I want to make sure you have the at hand for, my goodness, we've done on circles. They are. And you might want to having that little vocab cheat page that you've put together already, where you have little cards like ready. So looking at my notebook, I've got a little bit of space here at the bottom of this page where we did circumference. I'm going to skip it and I'm going to move straight on into the next page up to take a little bit. All about the sum. Just so that way we can a little more. Remembering that the sum of central angles had that definition where it was basically all the measures of the central angles, you add them together and you get 360. So in circle F, they want us to find the value for theta. Remember, theta is our placeholder value, their placeholder variable saying, hey, this thing's an angle. Theta. Use any variable you want. I like reserving out theta. I'm going to hand sketch a circle here. It doesn't have to be absolutely perfect, but there you go. Its center is F because that was given. And then from there, a bunch of I'm going to name my radii different letters. They are. And now I'm going to plug in, let's say the 30. Make this one a right angle, even though I know it doesn't look it, but we're going to mark it that way. Then this value here will be theta. According to that theorem that we had, sum of central angles added up to 360. And so I am just going to write all. Measure of this angle that starts here L, has its vertex F and goes towards H, plus the measure of the angle that starts here at H, has its vertex at F and then goes to S, plus measure of the angle that starts here at S, has its vertex at F and then goes toward L. All of those added together needs to give me rotation of the circle is 360 degrees. I'm going to go ahead and substitute what I know. The measure of LFH angle right here, that is labeled as having a measure of 130 degrees. So I can replace the measure of angle LFH with the number 130. Likewise, I can replace the measure of angle HFS, this angle right here, with 90 because it's marked as 90 degrees. Again, certainly doesn't look drawn as 90 degrees, but when we're doing diagrams, go with what's marked, not with what's like on how. Measure of angle SFL, this angle right here has the symbol theta inside of it, which means we are going to replace that measure of that angle with symbol theta. There is what we are looking for. There is our. All right, we're going to go ahead and combine like terms. 130 plus 90 is 200 and yeah, I double checked it on my calculator. 220. I'm going to keep theta for now because that's what I'm find. I didn't do any right hand. Subtracting 220 from both sides then will leave me with the measure of theta 100. The only way that I could make this more complicated was if I went through and put in some algebra. Go ahead and do that right now. We're going to use a very similar setup, but we need a different circle. So let's in circle M, find the value of each central angle. All right, so this one sounds a little more complicated already because we've got to find the measure of our central angles. Another word. Gonna sketch in the circle, so sketch a circle with me. Its center is going to be M, and then I'm gonna put in some, there's A, R, guess we'll do O over here, or this way we'll have an, so we've got our circle. All right, so we need to find the value of each central angle, which probably means that our angle measures are not going to be given values to us. Let's make this one given. Alrighty, so there we are. There is the measure of each of our central angles. We're going to use the sum of central angles. This calculate. Once again, the sum of central angles says that I can add up the measures of all of the angles that are coming out of the center of the circle. And when I add them all up, I'm going to get 300. So I'm going to start here. Of angle A, vertex at M, going through R, plus the measure of angle R, vertex M, O, plus the measure of angle O, going vertex M out to N, plus the measure N, vertex M, A. When I add up all of those, I need to get 300. All right, time for me to do substitute. I see that the measure of angle A through M R is x plus 10. I'm going to look then at the measure of RMO right here. That looks like it's 2x minus 5. Just substitute. The next angle is OMN, so that's this angle right here. And they actually gave me a number that's 100. I'm going to add the last angle measure that I have here, which is going to be NMA, which looks like it's this angle. Oh goodness, this pen doesn't want. Nope, this pen is dead. Okay, goodbye, pen. I'll use orange. This angle right here, and that looks like it's x minus. All right, and now I can do some algebra. I'm going to do some combining of like terms. I've got this x and these x's and this x over here. So combining those all together, I have 1 coefficient plus 2 is 3, plus 1 more is next thing is I'm going to do the numbers. So I have 10, 5, 100, negative. So 10 minus 5 is 5, plus 100 is 105, minus 4 is going to be 100. Oh, I lost count. Going to my 4-function calculator app because I clearly cannot keep track of numbers in my head. Here we go. 10 minus 5 plus 100 minus 4 is 100. All right, back to our, we've simplified it. We've collected all of our like terms. It looks so much cleaner and easier to handle now. I'm going to subtract 101 from both sides of my equation, giving me 4x equals going to my 4-function calculator because I don't know that off the top. 259. I can take that then and divide both sides by 4 because I want the x all by itself. When I've divided both sides by 4, I find that the value of x equals 64.75. But that wasn't the question. That was the first step to finding the question. What I was being asked for was central angle. Means I'm really interested in measure of angle AMR in the measure of O, measure of ON, measure of NMA. I got some stuff. So looking back up here, I've got that AMR is 10, but X is 64.75. Add 10 to that, get 74.75. I'm going to repeat RMO. RMO was 2x minus 5. X is, so I'm going to multiply that by, and then subtract 5. When I do that, 4.5. OMN was already given to me 100, so no more work there. NMA is as x minus 4. The value of x is 5, subtract 4 off, 60. And that's how you use the sum of central angles to calculate the measures central. The next video.